This is SpaceTime, Series 22, Episode 39. Coming up on SpaceTime, the riddle of the most distant object ever explored, solving a century-old mystery of ancient Egyptian desert glass, and China's Changë 4 lunar lander reveals new secrets about the moon's far side. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists with NASA's New Horizons mission say mystery still surrounds the formation of the most distant world ever explored. That remains the key question in the first detailed findings about the distant Kuiper Belt object 2014 MU69 ultima-thule. As they analysed the first sets of data gathered during the mission's New Year's Day flyby, the authors quickly discovered an object far more complex than originally expected. The findings, reported in the journal Science, have revealed much about this distant world's development, geology and composition. Located some 6 billion kilometres away, ultima-thule is the most distant object ever explored, and the first investigation of a well-preserved ancient relic from an era of planetary formation dating back some 4.6 billion years. The 36-kilometre-wide Kuiper Belt object is a contact binary with two very distinct, differently shaped lobes. There's a large, strangely flat lobe, which has been nicknamed Ultima, which is connected to a smaller, somewhat more rounded lobe, nicknamed Thule. How these two lobes got their unusual shapes is an unanticipated mystery that likely relates to how they independently formed billions of years ago. Like many binary worlds in the Kuiper Belt, the paths of these two worlds eventually intersected. They became gravitationally bound and began orbiting each other. Ultimately, some process brought them together in what scientists calculate must have been a fairly gentle merger. For that to happen, much of the binary's orbital momentum must have dissipated for the objects to come together. But scientists don't know whether that was due to aerodynamic forces from gases in the ancient solar nebula, or if Ultima and Thule ejected other lobes that formed with them in order to dissipate energy and shrink their orbits. The alignment of the axes of both Ultima and Thule indicate that before the merger these two lobes must have become tidally locked, meaning that the same sides always faced each other as they orbited around a common centre of gravity. New Horizons principal investigator Alan Stern from the Southwest Research Institute in Boulder, Colorado, says discoveries about ultima-thule can only help advance theories of solar system formation. The authors are also investigating a range of surface features on ultima-thule, such as bright spots and patches, hills and troughs, and craters and pits. The distant world's largest depression is an 8-kilometre-wide feature called Maryland Crater, which likely formed from an impact. However, it's thought some of the smaller pits on the Kuiper Belt object may have been created by material falling into internal voids, or due to exotic ices sublimating into gases and then leaving empty pits in their place. Another interesting feature is that, like other Kuiper Belt objects, ultima-thule is extremely red in colour, even redder than the much larger 2,400-kilometre-wide dwarf planet Pluto, which New Horizons explored at the inner edge of the Kuiper Belt back in 2015. In fact, ultima-thule is the reddest outer solar system object ever visited. Its reddish hue is believed to have been caused by the modification of the organic materials on its surface. Scientists have found evidence of methanol, water ice, and organic molecules, a mixture very different from most icy objects explored previously by spacecraft. The slow drip of data being transmitted from the flyby is continuing, and will go on until the middle of next year. In the meantime, New Horizons continues to carry out new observations of additional Kuiper Belt objects it passes in the distance. These dark, frozen worlds are far too distant to reveal discoveries like those on MU69. But the team can measure aspects, such as the object's brightness. And of course, New Horizons also continues to map the charged particle radiation and dust environment of the Kuiper Belt. New Horizons was launched back on January the 19th, 2006, from the Cape Canaveral Air Force Station in Florida aboard an Atlas V rocket. The probe made history on July 14th, 2015, when it became the first spacecraft to visit Pluto, and also studied Pluto's binary partner Charon, and their 4 moons, Styx, Nix, Kerberos, and Hydra. Pluto is one of the largest known bodies in the Kuiper Belt, a ring of frozen worlds, comets and icy debris circling the Sun out beyond the orbit of Neptune. The New Horizons spacecraft is now some 6.6 billion kilometres from Earth. It's operating nominally and speeding ever deeper into the Kuiper Belt at nearly 53,000 kilometres per hour. Ultima-thule is an ancient traditional name used to describe the most distant place known, a land well beyond the borders of the known world. In ancient Greek and Roman times, it was the place furthest north, now thought to refer to either Iceland or Greenland, although both the Orkney and Shetland Islands were also referred to as Ultima-thule in medieval times. I'm Stuart Gary. This is SpaceTime. Scientists have solved a 100-year-old mystery, discovering that glass found in the Egyptian desert was created by a meteorite impact rather than atmospheric airburst. The findings, reported in the journal Geology, have implications for understanding the threat posed by asteroids. The authors examined tiny grains of the mineral zircon found in samples of Libyan desert glass found over several thousand square kilometres of Egypt's western desert. Created some 29 million years ago, the canary yellow-coloured glass is nearly pure silica. One chunk was famously carved into a scarab that was part of King Tutankhamun's pectoral. The origins of the glass has long been a topic of ongoing debate as to whether it was formed during meteorite impact or during an airburst, which happens when asteroids explode as they hit thicker layers of atmosphere. The study's lead author, Dr. Aaron Kavosi from Curtin University, says the idea that the glass may have formed during a large atmospheric airburst gained popularity following the dramatic airburst over Chelyabinsk in Russia in 2013. The fireball and explosion, which was captured by dashcams across the city, caused extensive property damage due to the shock wave from the blast. Humans were injured mostly by shards of glass caused when the windows through which they were looking exploded. However, the blast failed to cause surface materials to melt. And that's where the Egyptian desert glass is different. Zircons in the glass preserved evidence of the former presence of a high-pressure mineral named Riddle, which only forms during meteorite impact. Previous models had suggested that the Libyan desert glass represented a large 100 megaton airburst, but these new results show this could simply not have been the case. Kavosi says meteorite impacts are catastrophic events, but they're not common. He says airbursts happen more frequently, but we now know not to expect a Libyan desert glass forming event in the near future, which is a cause for some comfort.
The first studies of this glass were the discovery that, for one, it was very high in silica. And the issue there is it takes a lot of heat to melt something that's almost pure silica. Silica is just common beach sand, quartz grains.
Lots of it around Egypt and Libya, I guess.
Yeah, that's right. Well, at least today there is. Of course, this was 30 million years ago.
True,
Egypt was rather lush back then. So the climate today in Egypt did not look like it did when this event happened. But sand is pretty common. We still don't know exactly what was hit to melt, whether it was a quartz-rich rock like a sandstone or whether it was something more like desert sand. It's hard to tell that. But there's abundant evidence for really high-temperature processes. There's minerals that only form under very high temperatures. Some minerals melted or reacted away, another process that only happens at high temperature. And I think the science community for many, many years was happy with the idea that this was some type of an extraterrestrial process because those kinds of temperatures aren't generated by normal igneous rocks. You'll never find something from a volcano in Hawaii that's anywhere near this hot.
The debate was whether or not it was from an airburst or a ground impact.
That's right. So early on, I think people favored the idea that this was a meteorite impact because at the time there was a lot less research into how airbursts work and what kinds of effects they produce. And so I would say through the 60s and 70s, even 80s, the idea that it was an impact gained a foothold. But there was always some nagging issues. And those were, for one, there was no source impact crater that had been identified where the glass could have been thrown out of. So that was the first problem. The second problem is that an impact event produces unique conditions in rocks in the Earth. When you slam a rock from space into the Earth at about 15 kilometers a second, you generate shock waves. And the shock waves really squeeze the rocks like an accordion. And that process creates a unique kind of damage in rocks and the minerals called shock deformation, deformation or damage that results from shock. And that type of evidence had not yet been found in pieces of the glass. And so that left room for other alternative hypotheses to rise up.
And I guess then we had the 2013 Chelyabinsk event, and that sort of brought the idea of an airburst into the picture much more strongly. And of course, people always in the back of their mind would have had what happened at Tunguska 100 years earlier in their mind as well, which was also an airburst.
Well, here's where things got interesting. People have wondered about the Tunguska event over Russia that happened, I think, in 1908, and that has generally been attributed to an airburst because, again, no source crater has been found. Combine that with advances in numerical modeling that came out primarily of nuclear weapons research design. And so people can do very sophisticated models of what happens when you detonate a nuclear weapon in the atmosphere. And because effectively what that does is it's a giant deposition of a tremendous amount of energy into the atmosphere, and there's all kinds of complicated physics that occur in that process. But great advances have been made in being able to model that, and that gave rise to people starting to say, you know what, the same or similar type computer codes could model this airburst process. And I would say that probably has been going on for 10 or 15 years in a modern way. And so the idea that, well, geez, a big enough airburst could really roast the surface of Earth with a lot of thermal energy. And guess what? It wouldn't make an impact. And because of that, there wouldn't be evidence of shock deformation. And so that seemed to fit the bill to explain Libyan desert glass as a sensible alternative hypothesis. And then, of course, the Chelyabinsk airburst happened in 2013.
But then you guys drilled into this, almost literally, I guess, a bit deeper, and you've gone back to the ground impact theory.
Well, here's the deal. The Tunguska airburst over Russia is modeled to have been about a 5 megaton event. Megatons is the amount of energy deposited in the atmosphere. The Chelyabinsk airburst is thought to be about half of a megaton, so even smaller than the one that happened in 1908. And the thing about Libyan desert glass is the way it had been modeled, it came across as a 100 megaton event, so a giant event compared to these historical airbursts. And that's kind of frightening if that's the case, where basically an asteroid thought to be about 100 meters in diameter could rip into the atmosphere and literally breathe fire onto the surface of the Earth and incinerate a large portion of it at very high temperatures. That's kind of a terrible thing to think about. This is what inspired another investigation of the Libyan desert glass that we started a year or two ago.
And so how did you do your research, and what did you find?
Well, one of my collaborators, Christian Kerbel, who's the director of the Natural History Museum in Vienna, had made several trips to the Egyptian desert to collect specimens of Libyan desert glass. Dr. Kerbel's specialty is impact glasses and detecting evidence of small amounts of the impactor that gets dissolved in impact glass when a rock from space hits and gets vaporized. And so there's some elemental analyses that are targeted to try to detect that. And he had previously detected such the presence of an extraterrestrial geochemical fingerprint in the glass. That still doesn't solve the issue of whether or not it's an impact or an airburst. We collaborated in our project. He sent me some samples of the Libyan desert glass that he had collected previously about a decade ago. And I took a look at them with a scanning electron microscope. My interest was to look for the mineral zircon, because zircon is a relatively common mineral in a lot of different rock types and also in loose sediment, loose sand. And it is an excellent recorder of shock deformation. And so the thinking was, we can take a look at some of these zircons, and if there was shock deformation from an impact, zircon would be a good recorder of that process. And so that was what we set out to look for.
Is that the same as shock quartz?
Spot on. Shock quartz is simply describes the same type of high-pressure deformation in the mineral quartz, which is much more common than zircon, or at least it's more abundant. Both quartz and zircon are found widely across the Earth in granites and sandstones and lots of other rock types. Here's the issue, though. with Libyan desert glass, it got so hot that it melted all the quartz. Most of the glass is truly glass. It's greater than 99.9% glass, and so there are very few minerals left. So it would be very natural to say, you know what, let's go take a look at some quartz in this glass and see if we can find evidence of shock deformation. But all the quartz melted, it's gone. I mean, it's still there. It just got transformed into glass. It got too hot. But the nice thing about zircon is that it's very refractory, and it just means it can withstand very high temperatures. And even zircon has a limit above around 1700 degrees Celsius, which is rather hot. Even zircon will break down. And most of the zircon grains we found in the Libyan desert glass had reacted. They got so hot they reacted to other minerals. And in doing so, they were fundamentally changed. But the great thing is about 10% of the zircons that we found had not yet reacted. And they're the ones that recorded the evidence of a high-pressure phase called reedite. A high-pressure phase means a mineral that only forms under the extreme crushing pressures created by an impact. This impact was so intense, it literally causes the atoms in minerals to jam much closer together than they normally are. And if it's very high pressure, it's enough to actually form a new mineral. And in this case, the zircons got squished enough to form this new mineral called reedite, and we could detect the evidence for reedite in some of these grains. That was the smoking gun in our study.
Okay, that raises the question then of why no impact crater?
Yeah, no, that's there's still lots of mysteries here that are out there and ongoing.
Or is it possibly there that's just buried and affected by the sands of time?
Well, pardon the pun. Yeah, it could be covered with these giant sand dunes that are in the area where the glass is found. It's quite interesting. The sand dunes are huge, and you go down to the troughs between these sand dunes where the desert floor is exposed a wee bit, and in between these dunes, that's where you find bits of rock on the desert floor, and that's where the Libyan glass is. And so one idea is that perhaps the impact structure is under sand dunes. That would also effectively be very effective in hiding it from satellite images. There's another possibility, and that is that it has eroded away or eroded so deeply that it doesn't really manifest as a circular feature on the surface of the Earth anymore. Of course, there's another idea as well, and that the glass was generated from an impact in the region, but perhaps not at that locality. And so the glass was ejected from somewhere else, probably in the vicinity regionally, maybe somewhere in western Egypt, and it landed in that area. The glass is spread out over hundreds of kilometers, and so it's not all in one location. And I'm going to guess that the shifting sands over time have indeed moved the glass around. And so it's not necessarily the case that right where you find the glass, the impact is required to be, because it's found over a big area.
That's Dr. Aaron Kavosi from Curtin University. And this is SpaceTime. I'm Stuart Gary. China's Changë 4 lander and its robotic Yutu rover have found that the geologic history of the moon's far side is far more complicated than scientists had originally thought. A report in the journal Nature has found that levels of the mineral olivine near the landing site don't match what was expected. It was thought that a molten magma ocean covered the lunar surface for much of its early history. As the molten ocean began to settle, cool and solidify, lighter minerals floated at the surface while heavier minerals sunk down to the bottom. The crust eventually solidified over in a sheet of Murray basalt, encasing a mantle of dense minerals such as olivine and pyroxene. As asteroids crashed into the surface of the moon, they cracked through the crust, ejecting pieces of the lunar mantle. Understanding the composition of the lunar mantle is critical for testing whether a magma ocean ever existed, as the hypothesis suggests. And that's important because the evolution of the moon will provide a window into the evolution of the Earth as well as other terrestrial worlds. That's because the lunar surface is relatively untouched compared to the Earth, whose surface has been dramatically reshaped by things like erosion, plate tectonics and volcanism. Changë 4 landed in the moon's South Pole Aitken Basin, the largest impact crater in the solar system. It's also the first spacecraft to land on the moon's far side. See, the moon is tidally locked with the same side always facing the Earth. There are great differences in the composition, terrain, structure, and the age of rocks between the lunar near and far sides. The far side is very mountainous, rugged and thickly dotted with impact craters, giving it a very different appearance to the large, flat, mare-covered near side. About 60% of the near side is covered in mare basalt. In fact, of the 22 lunar mare, 19 are located on the near side. The lunar far side is covered in lunar highland anthracite. Scientists don't fully understand the reasons for this geological asymmetry between the near and far sides, although they infer that the lunar crust is thicker on the far side than the near side. But because it always faces away from the Earth, the lunar far side is more difficult to study. Landing on the far side places any probe out of direct radio contact with mission managers back on Earth. China's solution involved first placing a communications satellite named Magpie Bridge into the gravitationally stable position in space known as the Lunar Lagrangian 2 position, 65,000 kilometers above the lunar far side surface. From there, Magpie Bridge can relay communications between the Earth and any far side lunar lander. This was followed by the launch of the Changé 4, which touched down earlier this year. The huge 2,500 kilometre wide Aitken Basin is some 13 kilometres deep and peppered with younger impact craters. Changé 4 and its Yutu lunar rover have been collecting spectral data samples from the flat stretches of the basin, as well as from the other smaller but deeper impact craters within the basin. The researchers expected to find a wealth of excavated mantle material on the flat basin floor, since the originating impact penetrated deeply into the original lunar crust. But instead, they only found faint traces of olivine, primary component of Earth's upper mantle. The absence of abundant olivine was a real concern. However, as more and more samples from deeper impacts were taken, greater amounts of olivine were found. Scientists now think that the lunar mantle consists of equal parts of olivine and pyroxene, rather than being dominated by one over the other. Named after the moon goddess in Chinese mythology, Changé 4 was originally built as a backup to the 1,200-kilogram Changé 3 lunar lander, which touched down on the Bay of Rainbows on the lunar near side in 2013. And like Changé 3, Changé 4 also carried a small 140-kilogram six-wheeled Yutu or Jade Rabbit rover, the Yutu 2, to explore the craggy and complex terrain of the surrounding landscape. By the way, Jade Rabbit was the moon goddess's pet. The Yutu 2 rover was deployed onto the lunar surface 12 hours after the Changé 4 touched down. The rover will need to explore much more of the basin to better understand the geology of its landing site and to fully understand the composition of the lunar mantle. I'm Stuart Gary. This is SpaceTime. A United Launch Alliance Delta IV rocket is blasted into orbit carrying a new United States Air Force telecommunications satellite. The Wideband Global Satcom, or WGS-10, is the latest member of a constellation designed to serve the armed forces of the United States, as well as its allies, including Australia, which has shared in the cost of the WGS project. The mission blasted off from Space Launch Complex 37B at the Cape Canaveral Air Force Station in Florida. WGS-10 was carried into orbit aboard a Delta IV in its medium +4-5 configuration.
Go. Rock, report range status.
Range green.
Stage LH2 secure at flight level.
Status check. Go Delta. Go WGS-10.
SRM PVC blowdown.
Rofi ignition.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-10 mission for the United States Air Force.
Passing 10 seconds into flight. RSCT chamber pressure looks good. See good chamber pressure across all four SRMs. Nice symmetric burn. 20 seconds into flight. Continuing to see good performance on the RS-68A engine. Now coming up on 30 seconds. Mach 1 Delta IV is now supersonic. SRM chamber pressure has tailed off from the max pressure as expected. Continuing to see good engine performance on the RS-68 engine. Delta is now passing through max Q, maximum dynamic pressure. Now 55 seconds into flight. Continue to see good performance on the RS-68A engine. Good performance on all four SRMs. Nice symmetric burn. Now 1 minute, 5 seconds into flight. About 30 seconds remaining until SRM burnout. Continue to see good performance on the main engine and standing by for SRM burnout shortly. And we have burnout on all four SRMs, standing by for jettison. And we have good indication of jettison of all 4 solid rocket motors. Main engine continuing to perform well. Chamber pressure looks good. Now passing 1 minute 50 seconds into flight. Vehicle's gone to closed loop guidance. The Delta IV rocket now weighs just 1/2 of its liftoff weight, burning propellant at a rate of almost 2,000 pounds per second. The second stage ACS system press valve has been opened. System pressure response looks good. And seeing good body rates on the Delta IV as it transitioned to closed loop guidance. Main engine continuing to perform well. Engine parameters look good. Launch vehicle is now 46 miles in altitude, 73 miles downrange distance, traveling at 5,400 miles per hour. Continuing to see good performance on the main engine, passing 2 minutes 35 seconds into flight. And body rates have nulled out now. And the upper stage lock system has begun the boost phase chill down sequence to begin thermal conditioning of the RL-10 engine. Now 2 minutes remaining in the boost phase of flight. And upper stage fuel system has begun boost phase chill down. Standing by for payload fairing jettison. And we have good indication of payload fairing jettison. Of stage separation. Nozzle extension is deploying. We have pre-start on the RL-10, standing by for ignition. And we have ignition on the RL-10. Chamber pressure looks good. Body rates look good. This is the first burn of today's mission. This first burn will last approximately 15 minutes, 15 seconds. Now passing 4 minutes, 30 seconds into flight. RL-10 chamber pressure continues to look good.
The 6,000 kilogram WGS-10 high-throughput satellite is based around Boeing's BSS-702 bus. It carries Ka-band and Ku-band transponders, providing some 8.088 gigahertz of bandwidth with downlink speeds of 11 gigabits per second. The US Air Force is now looking at commissioning Boeing to build another 2 satellites in the series, WGS-11 and WGS-12. And time now for a brief look at some of the other stories making news in science this week with the Science Report. Scientists warn that so little is known about the current population size and distribution of the black-throated finch that's affecting the government's approval of the massive Adani coal mine project that the true status of the bird is uncertain. A report in the journal Emu Australornithology says the establishment of adequate monitoring programs for the black-throated finch southern subspecies should be a top priority. Scientists found current understanding of the bird's ecology, threats, and optimal habitat are incomplete, and the absence of long-term studies limits their understanding of seasonal changes. The researchers, however, did find that more than half of the endangered bird's remaining habitat is within areas slated for the massive coal mine's future operations. Regular use of glucosamine supplements, which are normally taken to help joint pain, may also help lower one's risk of heart disease. The findings, reported in the British Medical Journal, are based on data on almost 500,000 British men and women. Scientists found that those who used glucosamine had a 15% lower risk of cardiovascular disease events overall. And the benefits among smokers were more than double those of non-smokers. Researchers say the link could be explained by the effects of glucosamine on inflammation, which plays a role in both cardiovascular disease and arthritis. It's official, the kilogram is dead. Long live the kilogram. On World Metrology Day, which was Monday, May the 20th, the definition of the kilogram was officially changed to be based on the Planck constant, a fundamental constant of nature that's inherently stable. Now, you may recall our story last November, when measurement scientists from around the world gathered in Paris, the home of the Big K, and voted to redefine the international system of units, including the kilogram. The kilogram was originally defined as the mass of a litre, a cubic decimetre of water. It was later represented by a platinum alloy cylinder, the International Prototype Kilogram, or the Grand K, manufactured in 1889 and carefully stored in Paris. However, despite science's best efforts to maintain it, the Grand K has diverged from its replicas by approximately 50 micrograms since their manufacture. By the way, the Planck constant relates to a light particle's energy and hence mass to its frequency. A cybersecurity issue has been discovered in Facebook's WhatsApp smartphone measuring app. The vulnerability allows hackers to remotely install surveillance software on a user's device. The popular messaging app was designed to offer secure messaging services for one-on-one or small group conversations. But as a result of this vulnerability, it's become a target for scammers trying to hack into users' confidential conversations and perform other malicious activities. Facebook has issued a patch in its latest WhatsApp update. Paleontologists claim a giant 40-ton dinosaur may have walked in a high-heeled fashion. The ancient reptile Rhodosaurus brownii was a sauropod dinosaur found near Roma in southwestern Queensland, dating back 160 to 170 million years to the Jurassic. Sauropods are those herbivorous four-legged dinosaurs that look like the Flintstones' pet dino. You know, the ones with an elephant-like body and legs, a long tail at one end, and a very long neck and small head at the other. The high-heeled walking posture is the best hypothesis scientists currently have to explain how such an enormous creature could have supported its own body weight. Reporting in the journal Morphology, researchers claim it was clear that Rheotosaurus walked with an elevated heel, raising the question, how was its foot able to support the immense mass of the animal? Remember, this is a creature between 25 and 40 tons in weight. They conclude that even though Rheotosaurus stood on its tiptoes, the heel was cushioned by a fleshy pad, similar to elephants' feet, but this dinosaur was of course at least 5 times as heavy. The authors arrived at their conclusion by creating a 3D replica of the fossil and then physically manipulating it in an attempt to understand the movement between bones, and comparing that to known sauropod footprints. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.